Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with the third video for my AIME series. Today's video comes from the year 2020, problem number 3. And I hope you guys enjoy this video, so let's get started. The problem states a positive integer n has base 11 representation ABC and base 8 representation 1BCA, where A, B, and C represent not necessarily distinct digits. Find the least such n expressed in base 10. So the first thing to note here is that base 10 is just our everyday numbers. All of the numbers that we use, they're all represented in base 10. And so I'm just going to give you a little brief introduction to the different base representations. So for base 10, for example, like I said, it's just regular numbers. So if we have 512, then technically how it's represented, it's 5 times 10 to the second, plus 1 times 10 to the first, plus 2 times 10 to the 0th. Because if we do this, we have 500 plus 10 plus 2, which is exactly 512. So for any number, if it tells us, for example, if it's in base 11, then it's whatever number times 11 to the whatever. And keep in mind that we always start with, for example, 11 or like 10 or, for example, base 8. It's always 10 to the 0th first, because 10 to the 0th or 8 to the 0th, whatever that is, it's always going to be 1. So that represents the ones digits. But going back to the problem, we see that we have base 11 with ABC. So that means it would be A times 11 to the second plus B times 11 to the first plus C times 11 to the 0th. So this would give us 121A plus 11B plus C. And then for the base 8, we have 1BCA. So it'd be 1 times 8 to the third plus B times 8 to the second plus C times 8 to the first plus A times 8 to the 0th. So that would be 512 plus 64B plus 8C plus A. And so even though these numbers, like this and this, even though they are represented with different bases, keep in mind that they're all the same number in. It's just represented differently. So we can technically set these two to be equal to each other. 121A plus 11B plus C is equal to 512 plus 64B plus 8C plus A. And then I'm going to move the A over to get 120A is equal to 512 plus 53B plus 7C. Keep in mind that A, B, and C, they all have to be positive integers. And A must be greater than or equal to 5 because once we subtract 512 over, it cannot be a negative number. So that means that let's just let A be equal to 5. That means we have 600 is equal to 512 plus 53B plus 7C. We're going to start with 5 because it's asking us to find the least such n. Subtracting 512 over, we get 88 is equal to 53B plus 7C. And then, again, because we're trying to find out the least such n, we can just let B be equal to 1. And also, if B is 2 or 3, then subtracting that over would give us a negative on this side. So once B is 1, we get 88 minus 53, which is 35. So 35 is equal to 7C. C would be 5. And so our answer would be 515. And this is represented in base 11. So we can convert that to base 10. So it'll just be 5 times 11 to the second plus 1 times 11 plus 5 to get 621. So our answer would be 621.